Anyways, let's continue further. Now we'll look at problem 12. And again, we have 26 problems plus that example, so that's 27 total. So we are well on our way, almost halfway of the video, or of the questions. So yes, we have problem 12. So suppose you have a large supply of books, all the same size, and you stack them at the edge of a table, with each book extending farther beyond the edge of the table than the one beneath it. Show that it is possible to do this so that the top book extends entirely beyond the table. In fact, show that the top book can extend any distance at all beyond the edge of the table if the stack is high enough. And then it says use this following method of stacking. So the top book extends half its length beyond the second book. The second book extends a quarter of its length beyond the third. And the third extends 1/6 of its length beyond the fourth, and so on. And it says try it yourself with a deck of cards and consider centers of mass. So we have here is our setup right here. So here's a top book right here. It's half distance. The next one, it's a quarter from the second one's a quarter from the next one. And the third is 1/6, and so on. Then it goes to 1/8. And in this case, there's 5 books, and it stops over at the edge here. So it's quite fascinating. So this entire thing is over the edge there, and it's still balancing. So theoretically, this can extend forever, or it would be a bit higher though, like a log curve. So extend forever. And yeah, we're asked to show that the top book can extend any distance at all. But first show that it's possible to do this so that top book extends entirely beyond the table. And yeah, to basically show it for any distance at all, which is quite fascinating, beyond the table. All right, so solution. First, let's note the pattern of distances in our construction method. So we have this 1/2 there, and this distance right here, this book is just given length 1. And there is 5 books, 1, 2, 3, 4, 5. So there's 5. And now what we could note this pattern. So this 1/2, you could write this as 1/2 times 5 minus 4. So that this just equals to 2 times 1. This equals 1/2. Now this next one right here, this equals to, well, 1/2 times it by 5 minus 3. Yeah, so 5 minus 3 like that. This equals 1/2 times 2, which equals 1/4. This next one, similarly, you can see the pattern, 1/2 times 5 minus 2. So notice this, it goes from 4, 3, 2, and so on. This equals to 1/2 times 3 equals to 1/6. The next one here, yeah, so these are getting bigger and bigger. So this, you're multiplying by a bigger number. And yeah, these are all just, yeah, it goes 2 times 1. This is 2 times 2, 2 times 3, 2 times 4, and so on. This next one is going to be 2 times 5 minus 1 equals to 1/2 times 4, which equals to 1/8. So you can see that pattern, and then there's flush with the book. Right there is the next one. Alright, so now that we have that pattern of these distances, so now let's place the y-axis and x-axis as shown below, and let the length of each book be L. So as opposed to this example, which is just 1. So the center of mass, called COM, just for short, is represented with a dot, and N is the total number of books. So what we'll have is, so let's draw our table. So here's our table, like this. And let's say that's the table, and there's the legs right here. I'll just put a leg like that. So that's the leg, and now what we have is, let's say we have our book flush with over here, right at the edge there, and this is going to be our dot center of mass there. And now what I'm going to do is draw the y-axis. So the y-axis is right flush with this right there, y. And the x-axis is right at the center, right there. So that's the x-axis. Alright, here, just fix it up, made this more flush, and just remove that so it can extend indefinitely. Anyways, so now this length up to the center of mass is L/2. Because the center mass is important to see if it's going to be tipping over or not. We have to make sure the entire center of mass is less than or equal to the edge there. or basically less than the edge. So we have this center mass is all the way up to here. And now that's the first book. And now the second book is going to extend like this. All right. And this distance right here. So this distance right here. And again, I'm going to make this in the center better. There's the center. And now this is going to be shifted over like that. And this distance, make this a bit more in the center. All right, so that's in the center. Now this distance is the same as from here to here. It's the same thing. We're shifting exactly the same. All right, let's delete this. All right, so that distance is the same, and this is equal to, as before, this is L over 2, then total number of books minus 1. Remember, that's the bottom one here. So total number of books in this case is 5, so minus 1, whatever the number of books is. So that's the pattern. And now the next setup is we add another and extend this one accordingly. Now this distance is going to be like this, make this black like that. This one is L over 2n minus 2. So yeah, you can see the next one right here. So this first one is going to be 1 over n minus 1. The second one is 1 over 2 times n minus 2. So the first one is 1 over 2 times n minus 1, n minus 2 over there. So that's fascinating stuff. All right, so continuing further, so we want to show that the center of mass of the system of n books lies above the table. That is, the average or the mean distance center of mass is of the whole system is going to be less than L. So in other words, it's less than the full length all the way across this L here. So that's L, so it's less than this entire thing. So the average, so the full mass has to be less than this setup here, has to be not beyond the edge. All right. So note that X with this bar on top is called X bar and represents the weighted average center of mass of the system. And the X represents it's in the X coordinate we're looking at. So the X coordinates of the centers of mass of the books are, so let's write of each one. So we have this one here is shifted. Notice how it's all shifted here by this distance. So for X1, the first book on the table is equal to is L over 2. X1 is L over 2. So L over 2 like that. And then, that's X1 is L over 2. X2 is equal to, well, L over 2 plus right here, which is L divided by, L divided by 2 times, and then divided by n minus 1. So L over 2n minus 1. So that is X2. And then X3 is equal to, X3 is equal to, well, we start off from here, and then we just add this extra distance. So we're just adding this extra bit. So it basically equals all that. So it equals L over 2 plus L over 2n minus 1, and then add the next distance plus L over 2n minus 2. And so on, and this keeps going on and on. Then what we get is Xn is equal to the nth book is going to be L over 2. L over 2 plus L over 2n minus 1 plus dot all the way. It keeps going all the way to the very end, and that end is going to be L over 2n minus, and notice how it's minus n there. It's one less than it, so it's going to be minus n minus 1 like that. Let's put a bracket n like this. And this equals to, well, this just equals to n minus n, it cancels. And there's a negative 1 times a negative is be plus 1. So, yeah, so this equals to L over 2 plus L over 2n minus 1 plus dot all the way until L over 2. So that's the final distance is going to be L over 2. As you can see here, the final distance is here is 1 over 2 for length L. So length L equals 1. There. All right, here I just boxed this in and wrote that in. So now we have this. So each book has the same mass. So assume it's all the same exact book. So if there are n copies of this book, or just n books of the same mass and same length, then the center of mass of the x-coordinate equals to the weighted average. So m of the book x1 of the center mass of that plus m x2 plus dot 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 plus m x3. So the total mass times the length, all divided by m. Alright, yeah, so this m divided by m times by the total number of books. So in other words, we get, yeah, the total mass. So basically, we're going to basically have an average mass. We have the total mass times by the average position of all of these. And these are all weighted by the mass, and each one based on how far they are. And yeah, how far they are, this is based on the x-coordinates we set up here. So starting from here, so this would be x1 would be here, like that, and x2 would be over here. Those are the centers of mass, and you're going to see the average center mass of the entire books. Alright, so then we have this, and we could factor out, or we could actually just divide out m on every single term like that. So it's not dependent on mass because they're all the exact same. So this equals to x1 plus x2 plus dot 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 plus x. This is this one's xn. This goes to xn, like that. All divided by n. And now this all equals to, let's put this 1 over n over here. And now x1 is equal to, well, that's x1 is just over here, L over 2. So that's the first one, L over 2, plus now x2, that is L over 2 plus, the next one is L over 2 and minus 1. And then L over 2 and minus 1, like that. Alright, and then that is that's x2. The next one is, just for completeness, L over 2 plus L over 2 and minus 1 plus, this is going to be L over 2 and minus 2, like that. So this is our x3, this is our x2, and this is our x1, like that. And then it keeps going on and on. So plus, alright, plus, dot, 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 plus, and then we're going to have now our xn, L over 2 plus L over 2 and minus 1 plus dot 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 all the way until L over 2, like that. And this whole thing is our xn, like that. And you can see that that's over here, that's our xn, like that. And now we could start simplifying and noticing some patterns. And that pattern as well, if you look at here, so there's an L over 2 here, L over 2 here, L over 2 here, and then all the way here to L over 2. In other words, there's n L over 2. So we could write this as, let's write this as, first write as 1/2, a 1/n. So 1 over n, times it by, now we have here n times L over 2, n L over 2. And now the next segment is, this is here. This appears here. This appears everywhere except the first one. So that means we're going to have plus n minus 1 times of L over 2n minus 1, like that. And then similarly, you could see over here, there is right over this next one is going to be L over 2n minus 1, minus 2. And this appears everywhere except on this on x2 and x1. So that means we're going to have it all the way across here, plus n minus 2 times L over 2 and minus 1. And then lastly, plus dot 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 plus all the way across here. And then this last one is just by itself, L over 2. And you can see that here. So this one adds it all, and then we removed all of them as part of this this dot dot dot, and the last one is just this L over 2. Yeah, because we have first we have L over 2 times n minus 1, that cancels. So everything cancels until the very end is the nth one, and that nth one, yeah, and that last one just occurs just once. And you can see that in this pattern here. So notice this L2 L2 occurs in here, but not this one. This one's by itself. This one occurs into this. And then this one occurs in this, and then you're always left with a 1 by itself. So in other words, we're going to be left with L over 2 there. So this becomes L over 2, like that. And put a square bracket. Alright, so what we have now is, well, notice all these all just cancel. Cancel, cancel. This is actually n over 2, not 1. Minus 2, so that's this one right here, and it'll all cancel. So this all cancels, and we're just left with that. And what we get is equals to 1 over n times it by nl over 2 plus L over 2 plus L over 2 plus dot 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 plus L over 2 in this last one. And then the total number of these L over 2s all the way across here, this is n minus 1 times. So that's how many times it occurs. You could see that here. So if you have this x2 L over 2, get that separate. So we're ignoring all the L over 2s in the beginning. That's for this n L over 2. And notice here, there's 1 here. Then there's a 2 here for this x3. And there's going to be n minus 1 for this xn all the way across there. Yes, which is quite fascinating. Yeah, and we can see the number 1, 2. For x4, we'll have 1, 2, 3. Yeah, 1, 2, 3. This is 1, 2 for x3. And this is 1 for x2, and so on. All right, so we have all that. So this means this equals to 1 over n, and then we're going to have a nl over 2 times, or plus n minus 1 times it by L over 2, like that. All right, so now what we'll do is factor out the L over 2. I mean this L right here, factor out this L out of there, and then we have the common denominators too. So we'll factor out the L, and then we're going to write this as, so then it's going to be n plus n minus 1 over 2, like that. And this combines together, we get L over 2, and then 2n minus 1 over 2, like that. Actually, this is not a 2, this is n. Yeah, n2, they look similar. So like that. Yeah, so in other words, we get here L over, and there's a 2 there, so L over 2n times it by, or actually put the L by itself. I'm going to put this 2n in front. So 2n minus 1, and put this 2n together, 2n, and then put the L like this by itself here. And now this top part is less than this one. So this is less than 1, because this 2n minus 1, yeah, 2n, put this, it's not a, yeah, so this is 2 times n less than 1. And that is less than 1, so that means that this is less than L, because you have a less than 1 number times by L. So it's going to be a less than L, that, like that. So that means that the weighted average is less than L, so it does not extend outwards. Yeah, so it's going to be less than L, where L is this. So the average of all this, the mass is going to be less than L. So in other words, it's not going to be tipping over, which is quite fascinating stuff here. Yeah, so this shows that no matter how many books are added according to the given scheme, the center of mass lies above the table, so it doesn't go over the edge. So that's quite fascinating. So it remains to observe that the following series is divergent. In other words, it's a harmonic series. So the distances, if we look at the distances here, so this distance 1/2, 1/4, 1/6, 1/8, etc. So notice that half set up here. So if we have that, so let's say we have 1/2 plus 1/4 plus 1/6 plus 1/8, and it keeps going on and on. Yeah, plus 1/10 and so on, 1/10, so on, plus dot dot dot, all the way. This equals 2. So then if you factor out 1/2, we get a 1/2 times it by, and then this times it by up to infinity, starting from n equals 1 of 1/n. So initially is 1 over, this one is 1/2 times, yes, this is 1/2 times 1, This next one is 1 over 2 times 2. Next one, 1 over 2 times 3, etc. And it keeps going on and on. And yeah, so 2 times 3 is 6, and so on. So this right here, this is divergent. This is a divergent harmonic series, as per my earlier video. And yeah, so here, this is divergent. I'll just write this down. Divergent. So in other words, this total goes to infinity, so distance can be as far as you want. So recall that the harmonic series is a divergent p series with p equals 1 from my earlier video. So the p series summation from n equals 1 to infinity of 1 over n to the power of p is convergent if p is greater than 1, and it's divergent if p is less than or equal to 1. And in our case here, n is to the power of p. N is equal to the power of 1, where p equals 1. So thus we can make the top book extend as far as we like beyond the edge of the table if we add enough books. We got infinite books, and so on.